Hello, this is Arnold. We will have a quick review on TGO primarily about the calculations. And in this video, we'll be starting with the Snell's law. But before that, let's have a review on the refractive index of different materials. Okay, so what I want you to look at are the values for the air, the water, the CR39, the crown glass, polycarbonate, maybe the flint glasses, and then the diamond. I told you this to look at because these are the common values that are always used in the examinations that are about Snell's law. But if you can memorize or familiarize here that is presented to you right now, that would be great. But do you? And then we have here the refractive index for our air, which is approximated to 1. You can also use the value of 1.0003, but that is almost the same with our approximate value here with 1. So no matter the case, that is almost identical. And then for our formula for the Snell's law is that it is n1 times sine theta 1 is equal to n2 times sine theta 2, wherein our n1 is the index of refraction of medium 1. So we can draw here. So this is our n1. This is a material. And then angle of incidence, so we can draw here the normal line. And what is the angle formed between the light and this normal line is called our angle of incidence. Angle of incidence asa siya gikan. So that is our angle of incidence. And then our n2 here is our second medium, the index of refraction of our second medium, and then our theta 2 or the angle of refraction is the light here na nasa n2 nato, angle between that and this normal line again. Okay, that is our angle of refraction. And then for our rule of thumb, if gamay ang ato n1 compared sa ato n2, that means nga ang ato light slows down and bends towards the normal, because the higher the n, magtikahinay ang speed sa light. Lower speed of light. Speed of C. Light. C means light. Okay? So that means na murag mabugatan siya. So padong siya duol sa normal. However, in contrast sa ato kuan, if dako naman siya, kung mas dako ang n value nga ri sa ato taas, nya padung siya sa ubos, so magtikagaan ang ato pagbend sa ato light, so meaning mo bend away siya sa normal, so mas dako na siya og angle nga ri. So that is one way to confirm if ang imo nakuha na answer sa Snell's law is whether correct or not. So let's have an example. So scenario 1, a light ray travels from air into a polycarbonate. So we can have here from. So gikan siya sa air. So we can actually draw na ana. So from air is n1. That is n is equals to 1. And our polycarbonate is Pili value sa polycarbonate. That is 1.586. So as we've discussed earlier, low n to high n man ni siya because from air to polycarbonate. So meaning our angle 2 or our theta 2 is lesser than the theta 1. Mas gamay ang ato angle of refraction. So inana na siya gitsura. Nabugatan siya. Okay? And then the light hits the glass at an angle of 30 degrees from the normal. What is the angle of refraction? So ang ato pangitawan is angle of refraction. So this value here is unknown inside the glass. Okay, so this angle of incidence here is 30 degrees. So ang ato gipangita na karon is ang angle of refraction. So how do we do that? So step 1, you identify your variable. So our n1 here sa ato example is our air, which is 1. Our angle of incidence is 30 degrees and our N2 is 1.586. Step 2, you set up the equation. So simply, ibutang nimo ang mga values na na-identify lang nimo bago lang. So 1 times sine 30 degrees is equal to 1.586 times sine theta 2. Mo niya nga to gipangita na value. And by that, nakakalculate na ta sa sine 30 degrees na to, which is equal to 0.5. Ang ato makuha na karon is 1 times 0.5 is equals to 1.586 times sine theta 2. So, ibutang ra nato ang value sa sine 30 degrees. So, of course, 1 times 0.5 equals to 0.5, and then we have here the value. But since we are still finding the value for our sine theta 2, so we divide both sides by 1.586. We divide both sides para ma-cross out ni siya. And then we have here, nabili na lang ato sine theta 2. Anya, ang nabilin nga rin kay 0.5 over 1.586, which is equivalent to 0.315. But that is not still a degree. Missing pa ang ato degrees nga rin. So, ang ato buhaton karon is we take the inverse sine. Take the inverse sine to find the angle para ma-convert ang ato value na 0.315 into a degree. So, our angle of refraction here sa ato first example would be 18.38 degrees. So that is our final answer for our first question. So ang value ani is 18.36. Am I correct? 18.36. 38. 18.38 degrees. So at sa ato pag-confirm is it ang ato angle of refraction kay mas gamay sa ato angle of incidence? That would be correct because ang ato 18.38 is mas gamay aning sa 30 degrees. So we're done with our first example. Let's now proceed with the scenario 2. A beam of light travels from crown glass into air. So from crown glass. So ang crown glass na to is ang iya n value, ato iya index of refraction is 1.523. Ang ato air as always is n is equals to 1. So, gikan siya sa crown glass. Butang na sa tanig normal line. Crown glass. So, gikan man siya sa mas dako nga index of refraction. Onya, gamay, padung siya sa gamay nga index of refraction. So, meaning, dako ni siya og ana. So, meaning, ang ato angle of refraction here should be greater than the angle of incidence. Muna ang ato expected value. Dapat. We measure the angle of light after it leaves the glass and find it is 50 degrees. What was the angle inside the glass? So, we measure the angle of light after it leaves the glass. Angle of refraction. So, angle of refraction ang ato 50 degrees. That is 50 degrees. So, ang ato gipangita karon is ang angle of incidence. Unsa ang angle na naa inside sa glass, which is the crown glass. So, we identify our variables. Our N1 is the crown glass, which is 1.523. So, gipangita na to ang angle of incidence. N2 is the air, and the angle of refraction is 50 degrees. So, we set up the equation that is here, and then we solve it with our cycles, and then we have here the value for our sine 50 degrees to be valued to be 0.7662. So simply substitute lang ara, and then we have to simplify. 1 times 0.7662 is 1.7662. And then we divide both sides by 1.523 para mahawa ni para mapabilin ang kining sine theta 1 nato. Okay? And then that's why ang nabilin nga kay sine theta 1 para makita nato ang ato angle of incidence. And then, after that, na natay value na yun ani, we go with the inverse sign to find the angle. That's how we got the value of 30.2 degrees. Let's check if mas gamay ang ato angle of incidence. Yes, mas gamay siya. Mas gamay ang ato angle of incidence. So, it still checks out. Okay, let's proceed with the third example. So you have a mystery gem. You shine a laser pointer through the air into the gem surface. The light hits the gem at an angle of 45 degrees, but inside gem, it slows down drastically and bends to an angle of 17 degrees. Identify the materials. So, from morning laser na to, this is the normal line na to. This is the first material and this is the second material. So our N1, we can suspect this is air. So that is valued for 1. Onya, ang value sa ato angle of incidence. So angle 45 degrees daw siya. And since bugat siguro yung material, that's why natay 17 degrees nga ri. 17 degrees. So since kuan man siya, since nga ri man siya na belong, mas gamay ang ato angle of refraction compared sa angle of incidence, we can assume nga ang ato second material has high index of refraction. Mo na ang ato clue. Okay, asan mo to? So, mana na siya. So, dapat mas dako siya compared ani. Okay, we have to identify our variables. So, our N1 being air is 1. Our angle of incidence is 45 degrees and our angle of refraction is 17 degrees. Now, we are tasked to find the index of refraction for our second material. So, simply substitute lang gihapon gamit sa katong Snell's law na ato gina-follow. But this time, ang N2 na ato gipangita. So, solve for N. So, simply substitute lang siya. Simply ipang-calculate lang niya siya sa mga cycle ninyo. And then, you will arrive with these decimal values. So, 1 times 0.7071 is equal to the same. And then is equals to N2 times 0.2924 and we divide both sides by 0.2924 para mahawa ning value para ang N2 na lang magpabili nato. So that's why our value for our N2, ang ato index of refraction sa ato second material is 2.418, which is approximately the same sa index of refraction sa diamond. Therefore, our material in our scenario 3 is diamond. And that would be all for my discussion about the Snell's law. I hope you have learned anything, and I would like to extend my thanks to Krys for helping me with my presentation on this Snell's law presentation.